Hello, everyone. Welcome to the 25th episode of the Day Zero podcast. I'm Spectre. With me is Z. For the first time, I think we started right on 3 o'clock, not like 3:01 or 3:02. So we've we've hit a milestone there. But yeah, we'll jump right into the news here. So first thing that we have is the Chromium Blog, where they put out a post on Tuesday about building a more private web, a path towards making third-party cookies obsolete. So we've talked about browsers in the past in regards to privacy, especially Chrome actually, and this post talks about a plan to try to develop a new set of standards to help enhance privacy, and its main focus, as you can tell by the title, is third-party cookies, right? Um, and it's used for tracking, right? And the whole idea is to hopefully phase out third-party cookie support within 2 years.
Yeah,
So
so I want to kind of jump in there, just mention that.
okay.
When we mention third-party cookies, in some discussions online, I've seen a little bit of confusion over what exactly they're talking about. Third-party cookies, obviously, are cookies that are not belong to the first party. You visit a website, Google, a cookie from any other domain is third-party to Google that you're visiting. For a long time, you haven't been able to just straight up go and be on example.com and have, a website from tracker.com, or set a cookie for tracker.com or that tracker.com could use, or whatever website you want to kind of toss in there as a third party. But what could happen is, say, Google or example.com could load an iframe or a tracking pixel that makes the request out to that tracking website that can then set the cookie for themselves. So that's the third-party cookies that we're talking about that Google's now blocking. There's kind of I've seen a little bit of confusion around that, so I just want to point out, it's basically when you load up any third-party website, in an iframe, image request, anything like that, making any external request, it's the cookies being sent or set there that they're looking to phase out. Although they're starting off by limiting insecure cross-site tracking. So essentially, requiring certain labels be set on the cookie so they can be accessed over HTTPS. It just seems like a really weird step to just be like, okay, use HTTPS.
I was a bit confused on that too. I was like, I guess I was just a bit confused on how that really addressed the issue, I guess.
I mean, I have to imagine there's a good number that just use HTTP because it's less performance. But yeah, I don't think it seems to really tackle the core issue. And this whole thing, I don't know, hearing Google, technically Chromium, talking about privacy.
I know.
Knowing that's
it just interesting.
Yeah, it feels artificial. It feels like they're using privacy as their launch point to kind of go for a regulatory capture of sorts. Google has all the information. They're able to use however many resources they've got to get your information that, okay, so let's phase this out so other people can't do the normal types of tracking, but obviously they still get their own sort of tracking.
Yeah, I mean, maybe we're just cynicists after all these years, but it does seem like that could be a very valid thought that they have. Yeah, I was thinking that too. I was like, it's kind of interesting that we're getting this post about privacy. Admittedly, it is from Chromium, which I think is technically separate from Google, right? It is.
They are, but I mean, obviously you've got Google's hands all over it anyhow. I don't think you can completely separate the two. In chat, we do have pointed out that third-party cookies over HTTPS are sometimes used for weird, complicated auth logins. Yeah, I mean, it's definitely used, I'm trying to think here if SAML does it. But I mean, yeah, there are systems to use third-party cookies. So one of the things that they're doing with phasing it out is taking advantage of the same site label. So you have to kind of set the same site label to lax, I think, is the policy that he set it to. Being a fairly new thing, I don't have them all remembered. It's just I think 3 options, like strict, lax, and something else for the same site label on the cookie. But I think you just have to set it to lax, saying yeah, okay, it's okay for third-party requests to include this cookie.
Yeah. So I mean, yeah, it does seem kind of weird for Google to take this stance. It could maybe be because of some of the more negative, press they've been getting lately in
Well, so
regards to privacy. Maybe this is
Firefox
trying to
has
take a step up.
started doing this in July or June. It was this summer.
Yeah.
Firefox started doing their tracking protection. They've been doing this with third-party cookies. I want to say Safari also does something similar. So I'm going to say that Google's kind of just following along.
Okay.
In that sense, they do seem a little bit late. I mean, it's a handful of months. It's not like they're years behind or something. It it feels a little bit maybe dragging their feet to see if it's really going to be adopted or people are going to care about it. And
Yeah.
apparently people have, and they're like, I don't think it's a negative change in any sense. I just have questions about what Google's real motives are for it.
Yeah. The thing I found the most interesting about the post is probably that they asked for people to give feedback on the web standards community proposals. So they link out a GitHub page and they're trying to get feedback from both users and advertisers and publishers and stuff like that. So it does seem like they're trying to get a they're not just kind of going all steam ahead with their own way. They are at least willing to take feedback from other entities, which I think is nice.
Well, there's that. I mean, so Google and Chrome haven't. It's not like the IE days. It's not where IE is just straight up doing its own thing. Google has a very heavy hand within the industry, within the W3C group. They obviously can push for their own stuff to get made a standard, but at least there's still that process there. So I can give them that.
Yeah. So there was a domain taken down last week as well, WeLeakInfo.com, which I think probably quite a few people have heard of. I know I've definitely heard of it before. I haven't used it, but I've heard of it. And so this service, as you can guess probably from the name, it was a site. It was a service that provided data from database dumps and stuff like that from many popular sites. That included plain text passwords, personal identifying info, stuff like that. And it was very accessible. I think it was only like $2 a day for like unlimited searches, so it wasn't like hard to access at all. And they claim to have indexed more than 12 billion user records for more than 10,000 breaches. I don't know if that's
that
valid,
seems pretty feasible to me. Honestly,
it seems feasible. Yeah.
I mean, I don't know what exact database they will have had, but I mean, the number doesn't seem absurd. And I mean, the thing is, like, this is all information that's generally out there. You are able to track down these databases yourself. They just put it up, you pay your subscription fee, and you're able to search it. So they have it up there in a searchable manner, which is kind of an interesting challenge, just to be able to search that much information, presumably reasonably quickly. I've been familiar with it. I haven't actually used them, so I don't know what their performance was like. But my understanding is with a lot of these websites, it's not like the performance is terrible and you're waiting minutes for a search.
That's probably what you're paying for, right?
That is what you're paying indexing, for sure.
You would expect it to be quicker. But yeah, so there was a joint operation by the FBI and authorities from Northern Ireland, the Netherlands, Germany, and I think they said the UK. And the site was taken down. So we have the Department of Justice, or the Attorney's Office page open here from the DOJ about it. And yeah, so it happened on the 16th. And they even arrested 2 people on suspicion of being staff of the site. So,
you think being staff of the site, not the actual founder or key administrator, just staff?
Yeah. So the last time something like this happened, I think, was around 2017 with LeakSource. At least that was what our original article said.
Yeah, I mean, that would be
the last big one.
The last big one. I'm sure some smaller sites have gone down between them. I mean, as the site goes down, more try and pop up and take their place. So,
yeah. So, I mean, obviously, I think it's a good thing in terms of security, though. Like, it is kind of a losing battle, just because, like you said, it's not hard to find other sites that are hosting it, or just finding, copies of the database dumps or something like that.
Yeah, so apparently these guys were also associated with selling some rats encryptors. I don't know, but in terms of just the data that they've got there, like, I mean, it is useful information for researchers to be able to see, find out about how passwords are like what types of passwords are being used, for example, to see certain patterns in that. Like there are reasons to do research on that.
Yeah.
Um, like I don't know enough about where the actual crime is, if it's with like the personally identifying information, if it's just because the data was illegally obtained.
I was kind of
Like
wondering that too, because when you think about it, all these services are really as search engines. So how are they
yeah.
classifying it as illegal? Is it because of the data that's in them? Like it could be like a slippery slope kind of issue.
Yeah, like
Obviously,
I don't know which or what the answer is to that. Yeah, at
yeah.
least with some of the cybercrime stuff, I have a bit more experience on this. I just don't know, and I don't really have any background to draw from to know what they're doing. Like my thought would be it's probably related to that personal information. I mean, there should be some privacy laws protecting that. I don't know for sure exactly what the law would be, but I mean it's one of those things that clearly feels wrong.
Definitely. But the one thing I wondered when reading this was, again, kind of like the last topic, is what is the motivation, I guess, for taking this down? Just because sites don't really get taken down by government too often unless they're causing a lot of financial damage, like torrenting sites and stuff like that.
I mean, you
Piracy
don't
related
always
stuff.
hear about but plenty of sites go down as soon as they're involved with some crime. Which I did mention. WeLeak did get involved apparently with selling remote access trojans and cryptors. So that also could be related to why they got targeted now. I had kind of the same question though, like why now? Why the sudden interest? Because there are plenty of other sites doing the same thing.
Yeah, and this does kind of make me wonder if maybe in the near future we will see some of those other bigger sites disappear. Because sometimes I know when the government goes on these kinds of, uh, offensives, I guess, against these sites, they usually take down more than just one. Usually they go after a few of them, right? So, I mean, I saw some people, I looked into this a bit, and I saw some people concerned that this could potentially hit Have I Been Pwned. I don't think that's going to happen, just because Have I Been Pwned doesn't actually provide the information. It just tells you if that account has been leaked in a database dump.
Yeah,
And
or
in
if
which
that
ones.
password has appeared, if you're using the
Or
password
that,
lookup thing.
yeah.
But no, I mean, Troy Hunt has operated in a very responsible way in terms of the type of information you're able to get there. While I can see the database dumps being useful for researchers, with Have I Been Pwned and what Troy Hunt's done with that is quite different, provides a very different service, and he's done so in a way that really isn't useful for attackers to use. Whereas this information, the databases, can be useful for researchers, absolutely useful for attackers to use.
Yeah. So it's one of those things where it's cool to see, it's nice that it's been taken down, but at the same time, they're just going to move to other sites. And that's exactly what somebody in our chat just said. Sledgington, this will just make them use hidden services. Yeah, people that were using that will just move on to something else until that one gets taken down, and then they'll just keep hopping along, because these sites, there's so many of them.
Yeah,
And
I mean,
they're not hard
cat
to
and
make.
mouse.
Yeah, exactly. So there was a post on A Sad Day for Rust by Steve Klabnik. I think I said that right. So I don't think we've really memed it on this show, but I know on Discord and stuff like that, we meme Rust quite a bit. So
Those are memes? I thought everybody was serious about that.
just use Rust, man. But yeah, so we meme Rust a lot, but this post actually takes it in a more serious tone. And it focuses around an open source project called Actix Web. Now, I hadn't heard of this before this blog post went out, but apparently it's a web framework. It's developed by a notable dev who's at Microsoft, I think. And from all accounts, from what I could see when I looked into it, it's a pretty respected project. It's one of those. It seems to be one of those highlight projects for Rust. To like try to get people to use it more.
Yeah, one of the big things here was its benchmark performance. It was coming up on top of benchmarks of different web frameworks, including those that weren't Rust. It was just all around high performance web framework.
Yeah. So people started looking into the code base because it's open source, obviously, and somebody found that it was using a lot of unsafe. And for those of you who don't know too much about Rust, unsafe is basically the keyword you use to access. You need it pretty much to access anything at like the OS level, anything at like low level, you pretty much need to use unsafe.
You're basically telling the Rust compiler that, hey, you can't actually check and make sure I'm doing everything safely, but I know what I'm doing and I'm doing things safe. So, just don't check this code, just trust me, is essentially what you're saying with that. And Rust has always had kind of the idea that, yes, I mean, unsafe needs to be there. Obviously, people have said just remove unsafe and it'll make all the code safe, but realistically, unsafe needs to be there, as Spectre was just saying, to do that low level access, to have direct memory access. There are just places where you need that exception. So you can't just get rid of unsafe code, but you can limit the use. And then when you go to audit an application, you can look at like, hey, you might have 50,000 lines of Rust. You've got 30 lines or 300 lines of unsafe code that really needs to be audited, really needs to be looked at and confirmed it's doing well. So the abuse and overuse of unsafe is a red flag when you're looking at a project if they use unsafe a lot more. And Reddit has previously kind of gotten upset with this project over using a lot of unsafe. Sorry, I kind of cut you off though, Spectre.
Oh yeah, it's all good. But yeah, that was like the main thing. There was a lot of controversy in the Rust community about it. So there were, people made patches, critiques were made. Apparently the author was pretty reluctant to accept patches. Apparently he accepted some of them, but rejected a lot of others and took a while and some pushing to actually get those patches through.
I'll interrupt you again here.
Yep,
just to mention that in particular with this case, what just happened recently is that a use after free was discovered. No proof of concept was provided. Just that the code was definitely handing out multiple mutable references to the same objects. So definitely like pretty clear that it could likely be exploited. No proof of concept was provided for that, but it seemed pretty clear cut that it's likely to have been a actual use after free. So a patch was submitted and a patch was rejected for not being interesting. So that's where people got upset on this one, was specifically use after free discovered. The pull request was made to fix it, and it was rejected because it just wasn't interesting. Obviously, people got mad at that, and the author walked away. Which is kind of the big thing here. The author of the project has just walked away from it. So go ahead.
I think the nail in the coffin too was they mentioned the smoke testing Rust HTTP clients blog post that got published, and that got quite a bit of attention. And it focused on that like amount of unsafe, and I think that kind of pushed the author over the edge into quitting. So I just wanted to like mention that was that did seem to be a contributing factor. So
yeah, and I mean, so as Steve mentioned in his blog post, like it is a sad day for Rust. It's a sad day just in general where anybody's kind of pushed a maintainer to drop what was a fairly well used open source project. So the fact that somebody's just basically walked away from that, like I could sympathize with being on the developer side a bit, where open source works hard, especially as the crowd turns against you. It sucks to keep working on it. At the same time, I mean, is there some sort of reasonable expectation that we should have of a maintainer to, for example, fix or accept patches on something? Like technically speaking, they're volunteers. We don't have we're not entitled to any of their time. We're not entitled for them to do anything. And that seems to be kind of the sentiment among a lot of developers in response to this. If you don't like the maintainer, just fork it and do your own thing. And then on the other side is there are those who are trying to hold the maintainers to some sort of standard they may not have agreed with, but is there some reasonable expectation when you start publishing and start pushing other people to use your product that there's going to be some level of maintenance?
Yeah, I mean, overall, it looks bad on all sides, as the tagline says, just because it looks bad, like you were saying, where the community kind of pushes a maintainer to step back and quit from their project. At the same time, I think it is reasonable to expect him to at least accept security patches, like with the UAF you were talking about. especially because it's a Rust highlight project, right? It's one of the like showcase projects for Rust, and I think that's fair that they would want to kind of patches to go through to at least fix security issues. I think that is a reasonable expectation. So it just kind of sucks on all sides. I think the community was a lot more harsh than it needed to be, and I mean, this is one thing about Rust, right? And this is part of the reason why a lot of people meme it, is that Rust in a way is kind of elitist, in the way that if your project isn't deemed to be written in a near perfect way, uh, you'll kind of get shit on for it, and that does seem to be true in a lot of cases. And it's kind of like C++ in that way. You're either criticized for not using Rust or you're criticized for not using it correctly. And I think that's one thing that's kind of held Rust back from being adopted by for more like serious projects and stuff like that. I suppose that's true of a lot of languages, but it seems to be more true for like Rust and C++. I don't know why.
Yeah, I don't know. I mean, I think part of it with Rust is because it does have that security aspect to it. Like, security was part of the design of Rust in terms of the concurrency promises and, concurrency guarantees. So, I mean, just the security itself can be kind of elitist too. So I think the fact that Rust's kind of a language that's trying to pander to that, trying to pander to systems programming, like it kind of hits a few boxes for that. And I think that that is kind of a good point about the Rust community in general. I do think the security community has some, or definitely has some blame in this.
Yeah.
Overall, just like it is kind of mentioned there, we're not entitled to them to spend any of their time fixing anything we want. I do think that a good steward of an open source software should be maintaining things and should be doing those things, but we're not entitled to them to do so. I suppose in a big way, though, we can make the same argument about like closed source software that you're just paying for. Technically, they can do what they want. If we don't like it, just don't pay for it. Realistically, though, pretty much everybody's going to have some understanding, some minimum level of expectation from that. And I think security patches are one of those really minimal levels that you can generally just expect with all software that's being actively maintained. And when you don't get that, backlash happens.
Yeah. So I did kind of want to use this topic as a bit of a point to talk about my thoughts on Rust a little bit. I think we kind of share thoughts on Rust as a language. I think it looks cool, but I don't think it's the language. Like, I think it's a good building language to build some nice concepts on that could potentially be adopted by other languages.
Yeah, that's kind of been my view. Is just I think Rust, like especially the borrow checker, some of its guarantees, compile time, those are things that I think another language is going to come along and build off of, take off some of the rough edges to it. Because there are definitely some rough edges with Rust, and I like what it's doing. I like that they're trying to innovate in some ways, trying to solve problems. I don't think Rust is quite the language that that's going to hit, like be hugely popular. They're probably not even really aiming for that, and at least Mozilla is kind of dogfooding it too, or they're using it internally, so it kind of has that going for it in terms of the long-term support. So I don't think Rust is going to disappear. I just do think that there's going to be somebody else that takes up the same torch. And that's kind of going to be where we move from Rust. It's going to be a little bit easier to work with. The other thing, though, with Rust is I think Rust is really good to pick up just when you're learning. Simply because everybody starts, well, not quite starts off with this, but your first project, you're going to start fighting with the borrow checker. You're going to start learning those really good code patterns and general architectures to keep yourself from making those concurrency or from raising those concurrency issues. And when you can apply that to other languages, you learn a lot about concurrency just fighting with the borrow checker. So I think it's actually a really good language to learn in that sense. Not necessarily because I'm going to go and start using it for everything, but I think you learn a lot just by learning the language.
Yeah, I mean, I think that's a good point that it's good for like learning. That being said, like because of the borrow checker and stuff like that, I will say I have given Rust a try and I didn't really like it. And part of the reason was it was a real pain in the ass to write even really simple things, just like because of how many checks and stuff are in it. And then you also have like long compile times because of all those compile time checks. So when you're working on bigger projects, it does kind of suck in that regard. So yeah,
Yeah, like I said, I think that's good for learning though, but it's not going to be my choice of language on most projects.
yeah, it's the same for me. So on the topic of languages, Microsoft opened up their repository for Verona, which is a research programming language for concurrent ownership, which is kind of related to Rust in a way, and it's actually heavily inspired by Rust. So yeah, so like I said, it's a research programming language, so it's it's in its early stages. It's not meant to be used at the production level or anything. They even say the
Yes, no
project is not
production
ready to be
use.
used. Yeah, it's not ready to be used outside of research. But yeah, they say it was inspired by languages like Rust, Cyclone, and Pony, I think is the other language.
Yeah.
So yeah, for those listening who don't know, concurrent ownership is basically, um, you know, the biggest thing when you're talking about that is races. When two threads acquire ownership of a reference. So the reason that could be a problem is you could have one thread's operation on a reference. It could subvert an operation on another thread, and that could cause really hard to track down issues. And it's also a hard issue to solve, because all computers nowadays are going to be multiprocessor, uh, and multi-threading is popular for like big applications, right? So you want to make sure that you maintain, if you're going to be updating something, that you have mutual access or mutual exclusion on that object so that you don't end up subverting another thread. And locking and stuff like that is very hard to do. So this language is
So
kind of
locking isn't that hard to do. Locking's really hard to do correctly.
that's a better way of saying
I
it.
know that's what you're getting at. And that's one of the key features here of Verona is their attempt to simplify um kind of how you get these locks, how you interact with them. So I'm not actually too sure since they're inspired by Pony. So Pony does a lot of this without actually locking. So I'm not sure how Verona's doing it. They're not too clear about that. I'm going to assume that they are locking just because they don't explicitly mention that they're lock free. But they kind of just introduce this idea of a cone, C-own, which is concurrent owners. I kind of brought it up here on stream. Literally just define your variable as a cone of X. And then the only way you can access it then is by doing this when keyword, which will run concurrently. So these can run as they kind of show. So you'll do like when var x equals your cone, and then I'll create this variable x that you can use inside of this concurrent block. That'll run at any point before, after, like inline as you'd expect, or it could run after your following code. So it kind of removes some of the guarantees about ordering when you use this when keyword. But that's kind of one of their big things they've introduced here is that cone, making it really easy to get an access to it, and to make it difficult for you to access without. It reminds me a little bit of like Java monitors. Obviously different setup for that, but yeah, it reminds me of that, just being right here in the syntax of the language.
Yeah. So the when keyword is basically means when exclusive access is available. So it's kind of like a high level thing to easily access locking.
Yeah, well,
without having to deal with all the intricacies of
it's
it.
like a syntax sugar for the locking plus concurrency.
Yeah. So that one when keyword, it basically schedules it, and then so it returns immediately. It doesn't block because it just basically schedules it. So when it returns, the code doesn't necessarily run, but it's scheduled. So I mean, I think this is actually kind of neat. I don't know if I haven't really actively gone looking for it either, but I haven't really seen this kind of idea applied before.
Well, this is a lot of like, promises and callbacks in like JavaScript. You do the dot then, and then you have your callback function that gets run whenever it's actually available, not necessarily inline. And in
Yeah,
fact, they do when they do the dining philosophers in their example, they use a promise. Like this is very related to the promises concept that you see a lot in JavaScript. And the other thing that they introduce here, the other kind of novel thing, is their idea of regions.
yeah, I was looking into that. It was a bit weird how it was worded though. Like I didn't entirely know what they were trying to say. Like I see what they mean by like grouping objects together
Yeah,
and
so
like
basically you get to group your objects and you don't have to do this, but you can have an owner of a group of objects. And then inside of those objects, they can cross-reference each other, have pointers to each other, whatever, freely within themselves, as long as there's just the one kind of owner of that group.
okay.
So that's kind of the idea. You just have this region that they're all allowed to kind of work together, have mutable references to each other, but they can't reference something outside of that. And then they borrow kind of the idea of like the mutable reference from Rust, using it as like an argument. You can get a reference to an object in some unknown region too. But the region itself is kind of one of their new ideas for the language. It's just kind of a change kind of to the fundamental idea of ownership.
I just wanted to address a question from chat. Is it like a memory barrier type thing with load and store assembly instructions, or more higher level control? It's higher level. Um, it's basically locking. It's a higher level abstraction of implementing locking. So it's not quite at like the instruction level. It's not like a memory barrier. It's at a higher level. So overall thoughts on the project. I think it's cool. It's trying to solve a problem which has, plagued a lot of big projects for a while. Think like kernels and stuff like that. I I don't really think we're ever gonna see something like this in the kernel within the next like 10 years or anything.
Oh, here
Honestly,
I thought you were going to suggest that we'll see the Linux kernel written in Verona.
uh, sorry to disappoint you.
No, I mean even
I think Linus
Microsoft
will have some problems with this.
even Microsoft mentions like, this is just the research language they're putting out.
Yeah, it's
They're
an early
not
stage.
they're still using everything else for themselves as normal. It's just, here's a new idea to play around with. Here's something.
Yeah. One thing of note that I thought was interesting with this language is they say in their like FAQ that one of their main goals is to try to make it so that they can explore some ideas, and if they work out, they can be ported to existing languages in a smooth way. So it seems that Verona, they're not perhaps production isn't even in the like timeline, like it's not even in their thoughts of making it a production language eventually. It just seems to be kind of a language where they explore some concepts, see if they work, and then hope that they can get ported into other existing languages that are already out there, which I thought was kind of cool. It's kind of like it's less selfish, I guess. They're not expecting like everyone to adopt a new language that they're working
Yeah, they're
on.
not pushing
It's
for it.
nice
I
that they're
like
kind of
this.
sharing to other languages. Yeah, I think that's cool.
Yeah, I mean, I like
Um,
this. It is said they're trying out some ideas that we can go ahead and just play around with, see how it works, see if it works. If you like working with this, I'll be honest, I'm not a big fan of how Cone looks. Um,
really? Okay. Why is
I
that?
I mean, so it's not. I think it's a positive move. I don't know. It comes down to the multi-threaded aspect, or like the concurrency issue, where you read code, you want to be able to read it in the order it's going to execute, and the fact that it kind of violates that in a surprising way. I mean, it's not
Hmm.
that surprising. I don't know. Just reading it doesn't feel right. At the same time, like I don't mind that syntax sugar once you kind of understand what that is doing. It becomes easy to access. I do like the fact that you're doing that at the variable definition level to say, okay, put this in a cone, so it can have some guarantees on how it's being accessed. Like that's a good thing. I don't like when you kind of have the code in different orders than what they're actually going to be executing, and that just comes down to kind of readability and understanding. That said, I have a feeling as we go forward with more and more concurrent code, as we get higher core count stuff, I have a feeling that we're just going to have to kind of give up on that idea in general and start treating code more like just independent blocks that are going to be executed at some point in some order.
I can kind of see what you mean there, just because like when you see code there, like inside of that when keyword, usually you're expecting that code to run at that moment of time when that code is hit.
Yeah,
But
like
we were
obviously
talking about how it
that it's not
basically,
going to, but
yeah, it's going to be scheduled, and I could see how that could kind of, like, if you have some bugs in terms of the ordering, I could see how that could be hard to track down, because it would be, sometimes it would work, sometimes it wouldn't, and if you don't understand the intricacies of the when keyword and how cones work, I could see that tripping people up, and I could see that being a gotcha that could bite a lot of people in the ass.
yeah, so
So
actually that's something we haven't talked about is the predictability of your runs. And something that they also let you do is specify, just to help with testing, basically. But you can specify for it to run your code in, say, 100 different orderings of everything, which is kind of a key thing. Rather than just fuzzing and hoping you get the right order, it'll actually run your code and it'll order these different blocks differently, so you get different runs every time to spot some of those issues.
okay, that's pretty
Which
cool.
is actually a very nice thing to see here. Like, definitely kind of helps.
I'll be
I
honest, I
believe.
kind of skipped over that systematic testing section. I probably shouldn't have. So
Yeah, so like that definitely is a useful thing there. Have to kind of see how it works. That's obviously bored. They mentioned they took that out from P and P sharp, which are two
okay.
languages I have not used, but um I think I want to say F sharp maybe has that also. I know I've seen that idea before, so there are other languages doing it, but it's a nice feature here to see too. And kind of jumping back with what we were talking about, I mean, that's just the thing. Like, these are great ideas to try, see how it actually works.
Yeah, see if it works in practice as well as you think it works in theory,
Yeah.
and then adopt to other languages if it does. So yeah, overall, really cool. I don't know how I missed that systematic testing section. Maybe I don't know. Maybe I
Well, it's at the
scrolled
end,
down and
so
it is at the end. I guess I must have jumped the gun. I think I meant to go back to it and then I just forgot. I don't know. But that's a cool point, and that is actually really nice. So I'm glad you brought that up. Yeah, so we like to talk about fuzzing a lot on the show, and we also like to talk a lot about neural networks. So there's a paper that kind of married them, and it's called Montage, and it's a neural network language model guided JavaScript engine fuzzer. That's a mouthful. So it talks about building a fuzzer that targets JavaScript engines and browsers, and this is a very big area. I'd say JavaScript engines and browsers are probably the biggest target for fuzzing right now.
oh yeah,
That's
I'd
where
have
all
to
the
agree
cutting
with
edge
that.
stuff
That's
is going. So that's cool that they're targeting that. So these researchers they're at a Korean university, and they've been working on a fuzzer that's based on neural networks. They call it neural network language model guided fuzzing, or NNLM.
yeah. So I mean, so the neural network aspect actually isn't too unique. There are other um options that try and train on or try and have a neural network to generate some of it too. They've definitely gone a little bit beyond that, specifically, the language model guided um, aspect that kind of makes this really interesting. And actually, their training data, I think, is what makes this kind of the most interesting thing. But like they've talked about lang fuzz, gram fuzz, and ifuzzer, which all just extract code fragments out from whatever seed file, and then ifuzzer actually use some evolutionary guidance to generate more data. Yeah, basically they're doing the simple just combine these code fragments as long as the grammar allows it, go ahead. um so what they did with this paper is they kind of asked the question, are there any patterns between the test inputs that trigger JavaScript engine vulnerabilities, and can those patterns be used to drive a fuzzer? And from that, of course, as you'd probably guess, because they're publishing a paper, they did have a couple observations. uh problems often arise in files that have been patched for other bugs. So, you find one bug, you're probably going to find more. And the JavaScript test code that triggers new vulns is often composed of code fragments that have already existed in regression tests. Which
Yeah.
is where I think the cool thing here is they chose to train their neural network, and they talk a little bit about how they chose to train it. They talk about long short-term memory based training. You can get kind of all the details about what they chose in terms of that. I don't think we want to dig too much into those specifics, but essentially they've trained their language model on the regression test suite. And I thought that was a really cool idea. I'm not sure if others are doing that. They make it seem like they're the first one to go for that. I'd believe it for sure. Just because of how they've kind of breaking down the code. When we refer to the language model, they use the abstract syntax tree. Like they're breaking it down at that level. It's not like the literal code all the time. I think they can generate, but they sliced it up into fragments based on the AST. But yeah, so they use this basically trained on the regression test suite, and they add in a little extra step to resolve reference errors so they don't get any crashes because, you have var A and, this other segment or this other fragment used variable B instead, so it just crashes. Like they tried to resolve those. And had pretty good results with this.
Yeah,
Jumping.
ended up finding 37 real world bugs. I found, and 3 of them I think were existing CVEs. So I do want to mention their main target that they hit was Chakra Core, and for those of you that don't know, that was Edge's old JavaScript engine. It doesn't use that anymore. They're using Chromium now. So yeah, Chakra, I think it's kind of cool that they targeted that for a few reasons. For one, they even mention it has more detailed commit logs. Like their commits have like CVEs right in them and stuff like that. It's not an actively developed engine anymore, so in a way I think that's a good test ground. You don't have to worry about things changing too much or at all in the future. So I think it's a cool language to test on. And it is fairly new. Like even though it's scrapped, it's newer than Chromium is and those types of engines. So yeah, it does target Chakra Core, and I think that is worth mentioning. I did want to mention something about the patterns you talked about as well. With those, the problems from engine files that have already been patched. The 2 files that they found had the most bugs were related to globopt and JavaScript array. And I just want to say that's not too surprising. Typically, especially in like newer browsers, JS arrays are notorious for bugs because of all the like interesting operations and stuff you can do on them. Like if you look at WebKit's early days, like almost every JavaScript bug at a certain point in time was related to JavaScript arrays. So not too surprising. I think those patterns are interesting though. And the second point with the JS test code triggering new vulns is often composed of code fragments that already exist in regression tests. Yeah, that is, I think, the most important one for the fuzzer, because I think the key idea is to mutate those existing regression tests created by the neural network to feed into the fuzzer. So sorry, Z, you were going to talk about the results, right?
Yeah, I mean, you kind of already mentioned a little bit about the CVs they found here. I just brought up their unique crashes of, just in comparison to some of these other things, they had 135 unique crashes, 36 of which were in common, and that was 15 CVEs, known CVEs, and 8 of them were in common with other fuzzers that they test. When they have like JS fun fuzz, like they talk a little bit about why they chose different fuzzers. They do just have random or Markov chains as being some of their generation methods. So they have some reasonable techniques being used here, and they still came up quite far ahead. So the Markov chain, I guess, did manage, or I'm saying Markov, maybe it's not chain. I'd have to go and double check. But that had 109 crashes, whereas theirs was 133. So it came out ahead of everything else, not necessarily by a lot. but by a lot more on most of the other fuzzers. Like iFuzz was 22 or JS Fun Fuzz 57. Basically, it looks very promising to me.
So it's also worth mentioning that it is open source. They do have a GitHub link in their paper. It's their group account, I think, is WSP-lab, so they have it up on there. Like you said, it looks promising. Obviously, when you're talking about fuzzers, the biggest thing, like, you can talk about performance and number of test cases and stuff it can run all day, but the metric that matters when you're talking about fuzzers is can it find issues, and they've obviously demonstrated that it can. With the, I think, 133 unique crashes and stuff like that. Like, that shows that it's fulfilling its purpose. It is doing its job. And it does look like kind of a new avenue for fuzzing, and I could see this being integrated into like cutting edge fuzzers. I will
Yeah,
say,
I mean,
though,
obviously, it's not going to be for everything, but it works for JavaScript or language fuzzing.
yeah. So I will say, like, I was a bit curious about the fuzzers they compared against. I do wish they compared against some better fuzzers, like FuzzIL, for example, which is Project Zero's JavaScript fuzzer. So I do kind of wish that they compared against that, because some of these fuzzers, like what were the fuzzers they mentioned again? I'm just trying to think.
So they have like this Markov fuzz, JS Fun Fuzz.
Yeah, so I think it was one of these fuzzers. It was kind of like, it just seemed to be kind of like a hobbyist project. I want to say it might have been like JS Fun Fuzz, but yeah, like,
Well, they
I just
talk
wish
about the
they.
specific tech, like JS Fun Fuzz actually gets called out as being one of the few doing something. I want to say that one was maybe another model guided fuzz or something. I don't recall. But I do
Okay.
remember they called out that one in particular for doing something.
Okay. But yeah, I just wish they kind of compared against more than just those three. But that's just like a
Yeah, I
personal
guess maybe
thing.
the well, I can agree to that. Just comparing with the fuzzers that are more widely used,
Yeah.
which is definitely a fair point. I do think they chose fuzzers more on the fuzzing techniques being used, to kind of get coverage of different theories that are kind of related to what they're doing.
Yeah. So, I mean, overall, I really like the paper. I'll say that. Like, I think it's a good paper.
Yeah.
I just, yeah, that was just like my only thing with it. Uh,
Yeah,
yeah.
and I think that's fair.
So another talk happened during the week at a LinuxConf AU 2020, which, it's, as you can tell, it's a Linux conference, and it was done by Case Cook. I almost said Keys Cook, but Z corrected me before the show to pointed out the case and quotations there. So you've probably heard of him before, especially if you've looked at like Linus Rants, because he's a active contributor to Linux, the Linux kernel, and the slides are about control flow integrity in the Linux kernel. So we've talked a little bit about this in the past. I think there was a white paper that was covering it. I'll talk about my thoughts again a little bit later, just for people who haven't heard of them before. But yeah, so this guy's been looking into this for the last little while, and he did a presentation at this conference, and it talks about some CFI implementation ideas that we've talked about before, and the progress on getting them into the kernel. So on page 41, I think, he talks about some of the progress that's been done on upstreaming the patches for CFI, and that's what was kind of new to this. We've already talked, like, we know that there's some support for trying to get CFI into the kernel, but this goes into some of the specifics of actually trying to get it there. Sorry. So yeah, they talk about shadow call stacks from Clang, which I think was the big thing we talked about before. And they say there's 15 patches that are expected for 5.6. The other thing is function pointer prototype corrections, which they say it's done for ARM64. x86 still has a patch remaining for that. Clang link time optimization, I think, is mostly just build script changes, so there doesn't seem to be too much needed for that. And then the Clang CFI, he says, is hopefully uncontroversial and should land quickly after link time optimization, given all the landed prototype fixes. So I did find that interesting, the hopefully uncontroversial, and like all these patches. I do kind of wonder if these are going to get blocked if these patches aren't going to go through, because these just seem like the kind of things that Linus looks at and is like really hesitant to put into the kernel, if he like even does at all. So I said I'd share my thoughts on CFI for those who are like new to the show or haven't heard them. My thoughts on CFI are this: it's the problem with it is, especially in the kernel, it's not hard to get around. Data-only attacks are very easy to pull off, and they're just as, if not more powerful than text overwrites or code execution directly. On the patches, I really do. I have a feeling they're going to get shot down by Linus or other maintainers. I could be wrong. I just have a feeling from the past that it's like a real possibility here from like past stuff I've seen. I don't know what your thoughts are on that, but I do wonder if like these patches are going to make it through.
I don't know. I feel like there's a good shot they'll make it through. There's definitely been a push for some of the security changes. We talked about it on another episode with some of the other things coming in there, like the PID-FD stuff. So I feel like there's definitely the move towards getting some of the security in, considering they've got the expectation for like the shadow call stack in 5.6 merge. I think there's a good chance it'll come in.
I mean, yeah. I what I wonder though is one thing I couldn't really find too much in the slides is like what's the measured performance overhead. If it's I don't think it's worth too much of a performance trade-off just because, like I said, it's not hard to get around CFI. It's good if you can get it in there, but when you're talking about kernel, the big thing is performance. And I mean, maybe I just missed a slide because there is quite a few slides. So, if I did, fair enough. But I don't really see too much.
You could always run your own benchmark.
That's true. But yeah, I didn't really see too much talking about the performance overhead, which is obviously very important when you're talking about kernel. So yeah, I mean, it'll be interesting to see if it goes through. Maybe we can talk, that'll be probably a talking point if it does end up going through within, the next little while. But yeah, I think it was worth mentioning that, that presentation happened. Some of you might find those slides interesting, so I just kind of wanted to bring it up and throw it out there for people who are interested in kernel stuff. So
actually, one thing, okay. Linux kernel, is it usually being built by Clang, or is it? I thought it was GCC.
So this is interesting.
This is just kind of coming to mind.
I think the Linux kernel is still built by GCC, but there is a push to move it to Clang, and I think actually,
well, because I noticed this mentioned on the upstream status here, Clang done. Question mark. That people have been working on doing this Clang build with Linux thing.
Yeah, I mean, there's a big push for it. I think a lot of the push has come from Android. Google's trying a lot to phase out GCC out of like their tool chains and stuff, even for userland. I think actually this year, January 1st, 2020, I think they're like deprecating GCC entirely for like building stuff. So yeah, I think Android's the big one trying to push for Clang for building the kernel. So I think there's a big push on that. Yeah, Android GCC has been deprecated in favor of Clang and will be removed from Android in January 2020 as per the deprecation plan. That was from Navital in chat. So yeah, there's a big push for it. So yeah, I think it's trying to move into using Clang to build the kernel, but it might not be there just yet.
Yeah,
I think that's where it is.
That's kind of what I expected, but I figured I'd see if you knew a bit more on that. So obviously this is all dependent on being built with Clang. That's Clang Shadow Call Stack, it's the Clang CFI. So at least that gives some, let's say, hope on still being able to pull off some kernel O days, but like you said, I mean, there are other options for exploiting than just violating the control flow.
Yeah. So talking about some exploits, there was a advisory put out by Microsoft, adv 200001. I don't know why they have to have so many numbers in their
probably just so it's a constant size. They don't want like a any sort of SQL injection if you have something too big, right? But yeah, this advisory, there isn't much information available. In fact, even the body here about the remote code execution vulnerability exists in the way script, that's copy and paste from like at least 3 other CVEs that they've put out advisories for. So they're not saying very much here. That said, because last week we had talked about the rumor about this, i.e., Internet Explorer Ode being exploited in the wild, this is likely that exploit that they actually have an advisory for. They're still not telling us much about it. The only thing we really can say definitively is that it's running in kind of the old or legacy JavaScript engine. Kind of the key thing is, in order to exploit it, you have to get like jscript.dll running instead of jscript9.dll. And there's ways to do that to get IE to run using the older engine. Basically, compatibility mode. You get RC. That's about all we know. Some people have tried to point out some of those other CVs I mentioned, but like I said, a lot of them are literally like copy and paste of the same content. I'll pull one up here. Literally kind of that same thing. A remote code execution exists in the way scripting engine handles objects in memory. Vulnerability, blah, blah, blah. It's almost exactly the same thing. It has the same mitigation.
So I did want to say, like, I saw some people talking about this and saying, who cares? It's just Internet Explorer. Nobody uses that anymore, which I think is a bit of an unfair take, just because there are things that use Internet Explorer under the hood.
Government still uses Internet Explorer.
Do they? I don't know.
I won't make any mentions of which, but yes, there definitely IE is still being used in some government locations.
Okay, that's one point, and I think some people don't realize that IE is also used under the hood for some stuff. I think even Outlook actually uses IE under the hood, so it shouldn't just be dismissed just because it's IE. It is it is more serious than that. So just wanted to kind of bring that up.
Yeah, well, I want to say, I mean, obviously Google has definitely taken steps at being a lot easier to embed now, or well, Chromium, but like building applications with web views in them, like on desktop, like your .NET web view, I'm pretty sure is still IE based.
It is. Yep.
I don't think they've, even though IE's maybe made that move over to Chromium, I don't believe there's been any move for some of those things. So yeah, where you see that, you're still kind of dealing with IE, even if it's not terribly obvious.
Yeah. So we had a last minute addition that you added for Netgear signed TLS cert private key disclosure. So I didn't really get a chance to look at this too much. So do you want to take this one over?
Yeah, this one literally was just today. And basically it's the private keys for the TLS certificates for routerlogin.net, routerlogin.com, and mini-app funjsq.com, which apparently is some Chinese VPN. Not too sure about the funjsq one. You can maybe do a bit more research. Like I said, this just kind of came out today. And yeah, so the private keys basically, it's just embedded in the firmware. Is essentially what the issue is firmware, it wants to serve this router login over HTTPS. So it needs to have the key somehow, and it's included that just right in the firmware, so anybody can pull that out. So yeah, private keys leaked, but I don't know. I don't have like a good recommendation for how do you avoid this. Obviously, people are upset about Netgear's terrible security because they've leaked this key. And we kind of talked about this when we were talking about the data center management application. I want to say last stream or the stream before. Getting that, if you need that certificate or if you need a certificate in use, obviously that it was a different setup for the data center management one. But with this one, if you want to serve it in HTTPS, what can you do? Well, you could serve HTTP and just not have a certificate at all, but you don't want to do that. You want to have encryption. You can go self-sign, but then clients are always going to get an error. So what's really your alternative to sharing the private, to having the private key on the little mini server, or the router in this case? The only thing I could really come up with is using like the Acme protocol. So like Let's Encrypt, but that requires being internet connected.
So, addressing the actual issue of the private key being in the firmware, I guess
thing is, how else do you get it?
a way around that would be having something like a trusted execution environment, maybe, that had the certificate stuff in it.
Yeah, but then these are all
read or execute only memory, so that you couldn't just or like.
So that is a fair possibility. It's just, low end routers. Are you really going to do like trusted execution on that? Like that's
a very steep
investment
where you should have a trusted execution environment. I agree. It's a.
I mean, it is. It's probably about the only real solution, actually. Because what I was just going to say, with Let's Encrypt or using the Acme protocol, one is validation of ownership. They can validate you actually have that IP. Like, so they'd have to roll their own sort of system to give out these certificates. And it just requires an internet connection. Which is another thing, because plenty of people are going to have their routers and they're not online. Plenty of people are going to be using it and will kind of have internet access, but that's definitely not a guarantee. So obviously a lot of places just don't use HTTPS. Go ahead.
I do just want to say, like, I think a trusted execution environment is a reasonable expectation. You're right that it is like an investment in terms of like development costs and whatnot, but like, I think
development costs, power, cost of the actual device, the consumer, everything goes up.
But even like for stuff like this, like these are usually provided by like ISPs and stuff, right? Like
well, these are the Netgear like routers, not the modem. Sometimes they'll kind of provide a modem in that. I don't know how popular Netgear is kind of for that. Usually this is still kind of bought. And don't get me wrong, Netgear has had kind of a history of some weird choices. One thing that comes to mind is just, having the Cloud Connect being needed for some management functionality in one of their business lines. Like, you needing to have it all online. So, no, there are other reasons why I wouldn't really consider Netgear personally, but
yeah, I guess I just think that like a TEE or something like that is a reasonable expectation for a router.
Yeah,
but, I don't want to go too much into that.
The other thing, though, is they'll mention here, there is a little bit of controversy around this disclosure. The private, this is the private key in here. You can pull your private key. You don't need to go dump the firmware yourself.
So you think you should have blacked out or excluded that?
That's kind of the thing. So Bug Crowd, like there is a Netgear disclosure or bug bounty that does not allow disclosure. So this person has decided to dump the key and just disclose everything and not participate in the bug bounty.
That's interesting.
They could have left something for attackers to do.
Yeah.
I mean, at the same time, it's literally just there. It's not like it was obfuscated or hidden away. It's just there on the firmware.
So it's worth mentioning there is actually a disclosure timeline further down the page.
Well, basically no response, yeah.
Yeah, they said that they reached out to Bug Crowd to establish communications. Bug Crowd responded, but they were unable to establish a channel outside of the bounty program. So they just dropped it publicly. So, I mean, yeah, so that does kind of tie back to what you were saying, I guess, about why they... I mean, they say that they were unable to establish a channel outside of the bug bounty program, but why wouldn't they want to communicate on through the bug bounty program? Is it because they wanted to publicly disclose and didn't want to
that would be my guess?
Yeah, that's like the only thing I can think of why.
Because, like I said, Netgear just practices a non-disclosure, and I mentioned this I think last episode where I support the vendor's ability to make that decision to non-disclose. I do think vendors should practice disclosure. I do think they should make that, but I do think it should be the vendors making that choice. At the same time, I also tried to mention last episode, or when we were talking about responsible disclosure, that while I want to support that, at the same time, the threat of full disclosure needs to be there. Otherwise, basically nothing's happening. Belika, I'm not sure if I'm saying your name right, but if you want to, we talked about kind of responsible disclosure. I believe it was the last episode, it might have been 2 episodes ago. We have responsible disclosure right in the title, though, and I'd say give that a listen. And I kind of go into at least a little bit more depth, but I'll say this: my views on disclosure right now are inconsistent and contradictory. It's not a good view. It's still something that's been going through some changes over the last few years.
So, what are your thoughts specifically on the part where we are unable to establish a communication channel outside of the bug bounty program? Do you think it's fair that they expect Netgear to establish a channel outside of the bounty program?
Good question. I think as researchers, we should be willing to work within the bounds being set by the company. In this case, I feel like Netgear, I feel like they're not acting in good faith in the sense
Netgear
of
the researcher.
Netgear.
Okay.
I don't think Netgear's acting in good faith in terms of their just general policy of non-disclosure. I don't think that is a good faith move. And would they make that? I don't know. I feel like the dynamic changes when both parties aren't acting in good faith. So should they, like, is it fair for them to expect that? Like, no, they're not entitled to that sort of communication, having any extra communication. They've already established something, and as a researcher, kind of work within that.
Yeah, I mean, I kind of feel the same way. Like, they set up a bug bounty program that is their official channel. It's kind of fair that they don't expect to be able to, or to have to open up any other channels of communication for that. But at the same time, from a security standpoint, trying to work with a researcher is like a good move. But here,
yeah, I think they should be open to people who don't want to participate in the bounty, don't want money, and would rather just disclose the vulnerabilities.
Exactly.
Like, I think that should be an option there. Like, I think like companies should be willing to disclose their vulnerabilities. I think that's something we need to push companies towards. I just do also believe it's ultimately their choice, and sometimes I do think they can have a good reason to not disclose something. In this case, like, I don't see it, and just having like the general policy of non-disclosure, just makes me lose trust.
I think overall, I think the researcher should have excluded the private key from the write-up. I think that should have been, obscured out of it.
Yeah, it seems just extra to put it in there. You can.
Yeah, it doesn't need to be.
It doesn't add anything.
Yeah. But at the same time, I do side a little bit more with the researcher than with Netgear. I think they at least tried to reach out, and I think that's on Netgear that they didn't try to reach out to them, even though they didn't participate through the bug bounty program.
Yeah, like, I'm not against the disclosure.
Yeah.
I mean, as the finder of an issue, I also believe they're free to disclose it.
Yeah.
I've mentioned for myself, I kind of go the non-disclosure route, although that has definitely been changing as, we're seeing bug bounties, as we're seeing that become more common. And again, I talked about that in another episode, so we don't need to have that discussion now.
Anybody who's interested in that can check that out. It was episode 24. We talked about that in.
Okay, so just the last episode.
Yeah. So the biggest piece of news that happened over the last week was the Windows Crypto API spoofing vulnerability, which Microsoft put out a advisory for. And so this was a vulnerability in the crypto API system and how it validates ECDSA certificates or elliptic curve cryptography. I always mess that up. That's why I just say ECDSA. So we knew it was going to be kind of a big issue. There was a bit of a hype train built around it.
It even has several names to it.
It even has several retroactively applied, though. It didn't come out with a name.
That's true. Yeah.
So
Well, apparently found by the NSA.
Yeah. So Brian Krebs put out a tweet or whatever saying that there's going to be some big news tomorrow on the day before this was put out. So yeah, seems to be an implementation fail by Microsoft. Like you said, it was even addressed by the NSA, so you could tell it was kind of a bigger issue. But the issue, as I understand it, at the technical level, was basically Microsoft failed to check a parameter that's used in ECDSA called G, or the generator parameter.
Well, so if you don't mind, I'll kind of give a bit more of an overview on it. Because it also has to do with the trust store. So you are right, that doesn't check the generator, but essentially what happens is Windows has... and also one thing is you don't really need to understand elliptic curve crypto to understand the vulnerability here. It helps a little bit, but it'll make pretty much perfect sense regardless. You just won't be able to repeat it by hand or something, which you wouldn't do anyhow. But so there's this trusted certificate cache. So, you make your HTTPS request to some website, circuit sent over along with the root CA cert. The circuit's validated and it checks that the certificate was indeed signed by the CA, and then it checks that the CA is actually in the local trust store, that it's one of the root certificates that your computer will actually trust. If it's one of the trust certs, then the root cert is added to this cache. And the cert cache is, stores the public key, and then later on, next time it sees it can just look, oh, I've already seen this root CA, it's good, I've got it in my cache. And that's kind of where the problem comes in, because of that second check, where if it's in the cache it just trusts it, you can create a certificate that matches one that's in the cache. And that comes down to how it gets validated. So what's kind of important there is, well, it checks the public key to make sure they're both still the same. When you generate the curve-based certificates, you can specify like this named graph. There's several graphs, or named curves, sorry. That, NIST has put out some named curves that you can just be like, yeah, it's on this curve. Here's my first point. And the way the keys work is you basically got your public key is equal to a private key value times your generator or your base point. Doesn't really matter what that is. I mean, maybe you remember some of your graphing from school, y equals mx plus b. This is y squared equals x cubed plus ax plus b. Is over, mod whatever. It's over a finite field, does some special math stuff we won't get into. But
I don't remember the last time I heard y equals mx plus b. He just took me down memory lane.
Yeah, well, like I say, you'd recognize some of this math. You might not know like the what a finite field is or anything like that, but you would probably recognize some of this. Actually, Thomas Patachek, I think, old co-founder of Matisano Security.
Okay.
He did a post on Hacker News which gives a decent little summary here, kind of going into some of the math behind it.
Oh,
and
cool.
You can
Nice.
give that a read on your own. The link will be in the description, which kind of talks a little bit about some of it. But the gist of it, like I said, is your private key actually just ends up being, some X value times, G, whatever value you set for that. You can control that in your certificate. You can be like, I want my curve with this generator. So if you're able to create a certificate that has the same public key as one that's going to be in that cache, basically you're able to spoof that certificate. So you basically set your private key to 1. So most of us kind of understand, multiplying, 1 times G, or your generator, equals public key. So 1 times the public key equals whatever public key you want. You control the value of what your public key is very easily with this curve. And that's the gist of what you need to do. That'll create you a CA cert that'll match something in the cache. It does need to be in the cache in order for this to work. But once it's in there, it'll match that, and you can sign your own certificates with it. And just kind of illustrating how simple that actually is. There's a proof of concept code out that's, not very long. And all this code does, line 4, it's reading the certificate. Line 5, it's getting the public key. Line 6 is blank. Line 7 sets private key to 1. It takes the original values, creates a generator based on, first parameter being the public key, and generates cert. So in their 13 lines, or 10 lines actually, 10 lines of Ruby, and you've done this, and it's not exactly anything too crazy to understand. Even without understanding all of the math behind it, the gist of the math is when you multiply by 1, you control what the value is.
That's a really good overview. So, yeah, I mean, of course, quickly after this was announced, plenty of people rushed to start writing POCs and exploits for this within just a few days. Which actually I saw a lot of people kind of, I guess they were kind of worried about how this could be used, because obviously, like I think I talked about it before. This was patched in, I think, like the latest Windows update, but there are a lot of people.
Yeah,
who
this was
a
patch
Windows.
Tuesday thing.
Yeah, so there is a lot of people who don't update Windows for reasons I've highlighted in the past, because they allow driver updates in that they shouldn't, and shit ends up breaking a lot. So this is one of those attacks where it could probably hit a lot of people. So it is probably worth updating Windows 10 if you haven't updated in a while. I actually have. I finally got around to going through the pain of doing that.
I mean, I don't find it too painful. I guess maybe you do, but this is definitely something that's reasonably easy to pull off. But it does require a privileged attacker, kind of on your network, somehow man in the middle, and you're being targeted for the most part with this. It's not necessarily something that's just going to be run, well, I'm just trying to think of, maybe some attacks that could be done online. You control, have your website, whatever website.
Yeah, I can't.
Yeah, no, I mean, I can't. You really
need access.
You're really going to need some control at that level.
Yeah. So somehow we skipped over it. We didn't even. We said it was a named vuln, named retroactively, but we didn't say what the name was. The common name I've seen given to it is CurveBall. There are some others.
Yeah, Chain of Fools is one of the other ones I've seen.
Yeah, I saw like some funny comments saying this is why you should name your vulnerabilities, so that like a billion people afterwards don't end up naming the vuln for you, and it ends up with like 15 different names it's used by.
Okay, so I actually want to comment on the name vulns, but I'm going to do that with our next topic.
Okay, fair enough. So I think we can move on to that topic, because you gave a really good overview of that one.
So, yeah, I guess the next topic here is CableHaunt, which is a named vuln. And initially, I was a little bit like, I don't think this needs to be named. There's actually somebody over in the reverse engineering Discord that went and pointed out, they do mention this is something that can be attacked through the browser. Completely fair point. I hadn't totally read over everything yet when I made that decision about it not being a named vuln. And so with this one, I guess really quickly what the issue is a lot of Broadcom cable modems, so seems like almost everybody's using a Broadcom thing. One of their, or something based on like their systems. You might not be told it's actually from them. You'll probably have it branded by your ISP or something like that. Basically there's a spectrum analyzer feature that it has, mostly used, so you can get some, debugging information about the data that's actually coming over into your cable modem, like over the cable. But you can communicate that with JSON over a WebSocket, and there's a buffer overflow in it, which, clearly exploitable, very clean, just stack-based buffer overflow. That said, now that I've mentioned what that is, let's jump back to the name CableHaunt. My initial thought was this maybe it's an issue, definitely a real issue. Does it need to be a named vuln? And it kind of got me thinking about why some of these vulns become named and others don't. Obviously, the big thing is if it has a wide impact, it seems to get a name. That's generally what's going on. But I feel like, where the name benefits is when we need to interface with non-security people, non-tech people. Giving it a name just makes it easier to refer to than
It's more accessible.
than like CV 2020-0601. That was the last CV that we were just talking about. It becomes a lot easier to talk about it. So in this case, CableHaunt is something that's going to impact consumers, cable modems at home from your ISP. It's a consumer impact people need to know about. So actually, name really makes sense. And with the last one, CurveBall or Chain of Fools or whatever, again, that's something that can potentially impact kind of consumers for the most part. So I don't know. I feel like my initial thought was maybe not a name vuln. Looking into this one more, because it really is something you might talk about consumers with, the name kind of makes sense.
Yeah, so I do want to go a little bit more into what you were talking about earlier with how it can be hit from the browser.
Yeah.
So, obviously it can be accessed. It's only really accessible from the local network. But if an attacker can get you to run like malicious JavaScript that can establish a WebSocket to the modem, that's how it can be hit. Like from
and
the
WebSockets aren't protected by like your same origin policy. And they found that most of these were vulnerable to DNS rebinding. So if you have to deal with cores or something, you've got that to get around with it, or to get around it.
Yeah.
That said, one of the things is where this comes from is from a reference implementation. So basically some reference code that was copied just over and over. So there's no like centralized update or anything like that. But it also means like all of these different modems are going to be pretty unique address spaces. So even while there apparently is no ASLR, there is non-executable stack. They weren't able to execute off the stack, but instead they had to do a ROP chain. And to kind of get to writing that ROP chain, you're going to have to get the addresses. Which kind of raised some questions to me towards how easy this is going to be to mass exploit. Like, they talk about all these people being vulnerable to it, but the proof of concepts that you've got, you have to go leak the firmware first and, get all your ROP chains with Ropper, and then it kind of does some magic from there. So, I mean, maybe the addresses... Go ahead.
Sorry. Well, I was just going to say, to build on top of that, like, they don't even know how many, like, modems are vulnerable, like, how many models or anything like that. Like, they have some lists, they have, like, appendixes and the, like, the technical report and stuff like that. But, like, really, they don't even know how many are vulnerable or how vulnerable they are, just because of how much has been copied. So it's kind of a mess in terms of trying to find, like, which ones are exploitable and which ones aren't. And, it's pretty difficult in that regard.
Yeah, I mean, it's generally just been by actually testing and seeing what's vulnerable. It's just... Oh no, the actual exploitation of this doesn't seem... Without a memory leak of some sort, without some way of dumping data, and maybe there is, and I just didn't see it, it's going to be difficult to actually kind of mass exploit this beyond just doing like denial of service. I do want to comment...
Sorry, go ahead.
No, actually, go ahead. I was going to jump on a different topic.
Okay. I was just going to say, I think this is something that's more targeted, or that'll be more useful for targeted attacks. If an attacker knows that their victim is using a certain router, or a certain modem, sorry,
it feels like there's probably a better way than this then. Maybe not, but...
Maybe.
I mean, yeah, that's what I can see. Like, because you have to have some good information about your target in order to do this.
Yeah,
or maybe we'll find that a lot of them...
exploitation.
Maybe we'll find that a lot of them have been kind of built. They have very similar addresses because they use a lot of the same code. And you can actually get off your gadgets in the same place. I mean, that's definitely a possibility. It just seems somewhat unlikely to me.
Yeah. The other thing I was going to say before I moved on was like, this is a pretty low hanging fruit issue. Like, and this just kind of highlights, like, I'm not surprised at all. A lot of code for this kind of stuff is pretty garbage. Um, and this is kind of a good highlight of that. And I saw some people saying, and I think it's like a good point, is that the problem with modems is in most cases they're supplied by your ISP. It's not really something that you can control as much as like even say a router, for example. So like it kind of sucks in that regard that you're kind of in a lot of cases you're kind of tied to the modem the ISP gives you. So
Yeah,
that
or at
is
least
like
for the
a
default.
consideration.
Obviously, most people like with some technical know-how are aware that you can usually buy your own and kind of bring your own modem, but
For most people, yeah, they're not going to do that.
yeah, on
Um,
average, people aren't doing that for sure.
and obviously these modems are like DRM'd, so you can't flash like a custom firmware on it or anything like that. You're stuck using the garbage that they push out in many cases. So you
Yeah,
know,
well, usually if you're getting from the ISP, you're renting, so they wouldn't let you do that anyhow, just because you
yeah,
don't technically own it. Uh,
yeah.
but yeah, I think we've kind of covered that, so I do want to jump back really quickly. One of the comments in chat from Elzif or Elzif, yeah, I don't know.
Alizif, I think is how you say it.
Elzif, okay. The people who use PS4 DNS on their whole network could be targeted with the MS's CVE. Please stop doing this. I'm not sure if you're saying please stop to us for talking about the limited impact of it. Um, if you're running a DNS you don't trust on your whole network, that's on you. You're opening yourself up to man in the middle attacks with that. Um, and there are absolutely places people can. I mean, any sort of malware writing into the host file, just anything even being on your network can potentially, intercept DNS requests and respond before the actual server does. I mean, there's definitely a lot of ways, but you do need that in. So if that in is you're running a malicious DNS server on your PS4 or something, that's the end. But our point is, like, you do need that sort of thing. Okay, I wasn't sure. So from chat, they just said, nah, just people in general, not you guys. So I'll move on from there. I did want to tackle that though. Like, it would be a fair point that there are kind of ways you can unintentionally, because most people aren't going to be thinking of that PS4 DNS as being malicious. And actually, I with the Metal Gear Online server, we have them use one of our DNS servers. Technically, we can go and start replying to, and for some reason, people do use like that DNS in general too, which I find really weird. And I had to actually add some checks so we won't be an open resolver and stuff. But people definitely unintentionally open themselves up to some of these attacks too. But it does take that sort of step.
Yeah. So we'll move on to RDP to RCE when fragmentation goes wrong. So this talks about the remote desktop gateway, which is a Windows Server component for RDP. And they talk about some bugs they found through patch diffing in that UDP protocol for RDG. So it's a pretty short blog post. It talks about some buffer overflows they found. I think they talk about two issues. Both of them are relative out of bounds rights. So I'm not going to go too much into the technical details of it, just because like
I mean,
it's
you
mostly
really
pseudocode
can.
stuff.
They're really
You really
easy
can.
to understand.
Okay, fair enough. So I think the first one they talk about is 2020-06-09. So yep, we can just scroll down to that one. So it's a pretty simple issue. They use memcopy here with a provided size, but they do some math on that size, right? So they have bytes written plus fragment len if it's over the buffer size, and they return error.
Yeah, so that's actually like that's not so much doing math on it. It's just basically saying like make sure you don't write more than the buffer size. The problem is that next line with the actual mem copy.
Yeah. So it doesn't take the offset into account. So if buffer size is 1,000, they say they can send a message with 2 fragments. So one is a length of 1, and then the second fragment has a length of 998. So it's still smaller than 1,000, but So 998 bytes are written to the buffer at offset 1000, which results in writing 998 bytes past the end of the buffer. So, because they don't take that offset into account, they can end up writing outside of the buffer.
Yeah, essentially, like I said, they use that fragment ID and they're just, so we jump here and write, and the next one, actually, they kind of they stay with their limit is on the number of fragments, but yeah, I mean, you can see in the code here, like, if you control fragment ID, you can get your data being written pretty much anywhere, as long as you can pass that buffer size thing, which isn't really too hard of a check. I mean, it's a pretty straightforward issue here. And this is exactly what I was thinking of in our title here. Have we all forgotten how to write good code? I was thinking about this code.
Yeah, I figured. The second issue is also in that same line. It's the one right under the first red box, which is this frag received fragment ID equals true. They don't properly check the fragment ID, so you can basically get like a write 1 anywhere relative to that buffer. Anywhere between 0 and the max value for.
So the key thing is that array has 64 entries when they allocate it. So they're expecting no more than 64 fragments to be sent in. So beyond that is you're writing outside of the array.
Yeah. So with both of these issues, oh, sorry, were you gonna?
I was just going to mention. So the thing to remember is this is over a UDP. So, like, these fragments don't have to arrive in order or anything like that. So you can just right off the bat say you're sending fragment 65,000, whatever the short max is.
Yeah. So, obviously, with both of these issues, one thing they point out, which is a good point, is because you have kind of these controlled out-of-bounds writes and not just, like, smashing the stack, just overwriting a buffer, like a linear buffer overflow, it is a lot more controllable and exploitable because you have that control of exactly where you're writing outside of the buffer. So that's pretty cool in regards to like how neat the exploit is and how useful it can be. So I just wanted to mention that because both of these bugs they seem like very exploitable issues. So they talk a little bit about the technical details of that. They also have a section on like the mitigations you can take if you're unable to install the patch for some reason. They say you can just disable UDP transport or firewalling the port to prevent exploitation.
Yeah, so mitigation's pretty straightforward.
Yeah, so not a huge blog post, but it does talk about some interesting issues. Yeah. So talking about WordPress, there was some WordPress news in vulnerabilities discovered for InfiniteWP and WP Time Capsule. So I'm not a WordPress person, so I wasn't familiar with these plugins.
Yeah, and I haven't used them either. But I mean, everybody likes to hate on WordPress, so here we go. But this is a WordPress plugin. It's not it's kind of like if you get mad at your kid's teacher because one of the other students wrote an offensive paper. It's WordPress has been reasonably respectful the last several years. We don't have a lot of issues being found in the core of WordPress, but a ton of issues in WordPress plugins, and the people running WordPress blogs don't know the difference between a good and a bad plugin. Let's just run everything. That said, these are some interesting issues.
Yeah. So these plugins apparently, I looked into them a little bit. They seem to be a plugin to allow people to manage multiple WordPress sites from like a centralized management panel. I might be getting that wrong. I just took a quick look at the plugins. But yeah, so for InfiniteWP, they talk about like a PHP function that basically checks if this action parameter on this certain API is equal to re-add site or add site, and both of these are just basically missing authentication checks. So it takes a username parameter and it doesn't do any further checks, so there's an auth bypass there. And then the time capsule one, it's pretty similar. I think it's just if a payload contains this certain like JSON prefix.
And I heard people saying that they thought this could have been a backdoor. It kind of looks like it. I mean, this seems more like one of those things that somebody does because they're really lazy. This WPTC login as admin function, So basically, like you mentioned, it looks for that IWP JSON prefix, just if it's in the string, does a log, and then literally just goes, searches for all the admin accounts on WordPress, and logs in as whatever the first one is. It seems like, whoever wrote it was just kind of being lazy and is like, and we need to be admin to do this, so let's just be the first admin we can, and went through and did it.
Yeah, it was a really silly issue. That being said, I think they do deserve some credit because they say that when they actually reported this issue, the plugin author fixed it within like a day of the report. So I know like these are some pretty low hanging fruit issues, and like you said, they are like seem to be like lazy, like backdoor type things. But
Yeah, so I don't think it was a backdoor personally, but I definitely saw
well,
some rumors
when I say
about that
backdoor, I
idea.
mean like a development backdoor or something like that. Like not like a malicious intent backdoor, you know. More just like something they did in development, forgot to remove in production, something like that is my guess. So yeah, like pretty low hanging fruit, but they were patched quickly, and I think that they deserve a bit of credit for that. Overall,
I would
I think
not want to be
this
the get blame for it though.
the kid playing that guy. I mean, this just is another highlight, I think, of that there needs to be more attention in terms of security on WordPress plugins. I think they've been bad for a while, and it doesn't really seem like they're getting any better, really, in terms of like how
What
well
can
they're written.
WordPress do though? I mean, it's literally
Not
you're
on Word.
running
No,
PHP from somebody else.
I should clarify. Like, I'm not blaming WordPress for this at all. I'm saying that perhaps there needs to be more people looking at WordPress plugins.
There's so many
And
plugins though, and everybody just kind of rules their own thing. I don't know. I feel like the better option, actually, it won't be a better option, but yeah, I don't know what a solution here would be.
it's a
Just
hard issue to
because you
solve.
have this already kind of set up, like if you just remove that, if it wasn't just straight up, run your own code, they could add in a lot more limits, but it would also be a lot less functional in terms of what you could do.
I mean, I guess what I was just trying to get at there was like, I think there needs to be more pressure put on WordPress plugin devs to secure their plugins better.
I think
I
there
don't.
has been, to be fair. I think, compared to, 2008 to now, I think there's a lot more pressure for security.
Yeah, I mean, one thing I guess that I was saying that I'm not really blaming WordPress, but I guess maybe there should be more auditing in terms of what WordPress allows as like official plugins that can be used. Like perhaps they should be more
That's kind
thorough
of
in
becoming a
auditing them.
walled garden, though,
Hmm.
which I'm not really going to support.
We just got 50 bits from K9, so thank you, dude. Just wanted to shout that out a little bit. But yeah, I mean, WordPress plugins, it's not much of a surprise that there's issues, but yeah, I think they do deserve a bit of credit, the plugin authors, that is, for fixing it as quickly as they did. Not too much more to talk about there.
Yeah, no, I do agree, though. Like, the patch time was great, and I think that's kind of a sign of the fact that some of these plugin developers do care about the security a bit more than they have in the past.
Yeah, I think in a lot of cases, sometimes like some of them, they just be like, yeah, I don't care, whatever, it's not going to be used. Like, this guy took it seriously, so that's pretty cool. And I think there's some other plugin authors out there that wouldn't take it as seriously as he did.
Yeah.
So we're ending off with kind of a fun topic, and this was another blog post by Seguza, and I think this is 2 weeks in a row we've covered a blog post by him. So it's called Cuckoo. I wasn't sure why he named it that. I think he meant to do cuckoo, but I don't know. I wasn't sure about the title, so all right. But yeah, it talks about an issue in iOS, an info leak specifically, and this info leak has apparently existed in the code base for 20 years. So that's what was kind of the big thing about it, was like it's been in the kernel for a long time. And the subsystem of where the vulnerability is in IOKit. And this isn't too surprising. IOKit has been a bug farm in the past. I don't think it is much of one anymore. A lot of the bugs that are in it have kind of died. But it has been notoriously buggy in the past, so it's not too surprising that the bug was from this area. But yeah, so it delves into the bug a little bit and some IOKit specifics. And if we go down to the bug section, they say that IOKit drivers frequently use callback mechanisms, and they're usually built around mock ports. And while there's no standard way to do that, a lot of drivers use this AS async reference 64 type, which is basically just an array of uint64s, or pointers rather, and it's like 8 of them. But they have a typedef IO user reference T, and what this basically tries to signify that the value should come from userland. But they do something really silly. They actually use the first field of the array, which is reference 0, and they set it to the mockport object itself, which is obviously a kernel object. So when this structure gets copied out to userland, you end up getting a kernel pointer as your first reference to the mockport. So it's like a really easy to understand issue. It's not hard to figure out what the issue is here at all. All they did to patch it was they just excluded the first reference from the copy out. They started copying out from reference 1 onwards. So yeah, it's kind of funny that such an obvious issue survived for so long. He says that there were like quite a few people who knew about it, but yeah, it finally died. But yeah, like
Finally died
funny...
thanks to Project Zero, apparently.
Yep.
At least that's the theory.
Yeah. So, it's a funny issue. Obviously, like, it's not going to get you, like, a jailbreak or anything. I've seen some people posting, oh my god, is this going to mean new iOS jailbreak? This is an info leak. Obviously, an info leak is still very valuable. It can be very useful in exploit chains, but on its own, this isn't going to get you, like, code execution or anything like that. It's something that's nice to chain with other bugs. But yeah, it's just kind of a funny issue, and usually in iOS and stuff like that, you don't see these kinds of easily accessible, easy to understand issues. Usually they're a bit deeper. So, it's kind of fun to see that, there is still some of these easier accessible issues that are in the kernel. Yeah, so just kind of a fun blog post. I think it's definitely worth a read if you're interested in kernel stuff.
Yeah, so kind of jumping off the easily accessible aspect, Mikyolo Swayham in chat mentioned a little while back about diffing a Windows vuln in file header parsing that resulted in a UAF, and that was just impossible to figure out. Sorry, I am summarizing this, not reading it exactly. I don't know how they find shit like that just by reversing. Makes me feel so stupid. A big part of it, and I haven't found those types of issues, so I'm not going to speak from a lot of experience, but a lot of it does come down to having a very intimate understanding of what you're targeting. You don't get to that point overnight. Realize that, and some of it can be a bit more directed testing, not necessarily fuzzing, and maybe it was purely reversing, but it could be some dynamic assessment too, noticing, hey, something's not right here, something in the past hasn't been right here, and kind of coming across it that way. But a big part of it is the more time you spend in a particular code base, you start learning how that's archaic. You start getting that same understanding that the developers have, and you work from that to kind of find some of those deeper issues. I wouldn't say you should feel stupid for not getting it if you haven't spent anywhere near as much time in the code base as somebody else has.
Yeah, I will say, like, file header parsing, those kind of file format issues are typically found through fuzzing. That is like a very popular target for fuzzing and finding issues. So it very well could have been through fuzzing, honestly.
Parsing is a really common place to look for bugs in general. Anything that tries to step manually through something is a good target for finding issues. It just seems very hard to get that right.
I will say I'm a bit surprised the UAF was found, though, in header parsing. That seems like kind of a weird issue to find there. But yeah.
Oh, no, I mean, if you're using it, you fill in an object with it. Oh no, I can kind of see it.
Yeah. I mean, yeah, I don't think you should feel dumb for, like, finding it hard to figure out how it works. Some of those file parsing issues, especially when you're talking about trying to figure out how to exploit it, it can be very difficult. Especially, like, since you're saying it's a Windows vuln and it's file header, if it's something like PE is a pretty complex format, especially even compared to like ELF. PE is, pretty crazy. So I don't know if it's PE. I'm just guessing it is, since you said Windows and file header. It could be something else, of course. But file format issues, they can be a bit harder to like figure out the issue and step through it. So when you're talking about exploitation, like if it takes you like a few weeks or a few months or anything like that to try to figure out an issue, I don't think that's worth feeling bad about. It can be frustrating, but that is part of the thing. Like what's the thing you love to say, Z? Frustration is a key to success, or something like that. Something motivational. I don't remember what it is exactly.
Sorry, I wasn't getting unmuted. Yeah,
Okay.
Frustration is a key part of exploit development or exploit research or whatever you want to fill in there. Frustration's always part of it. I mean, that is just part of the game. It's part of the fun. You're frustrated. You're banging your head against the wall, banging your head, trying to find that crack, and then you find that crack, and you start banging your head against that crack until you get through on something. I mean, it's a lot of frustration, but in the end, I'd usually say it's worth it.
Just makes it that much more enjoyable when you do finish it.
Yeah. And I mean, you learn a lot in that frustration, too. You might go down those dead ends, but those dead ends a year later might start helping you out. Oh yeah, I remember a year ago I researched this topic for like 40 hours. That didn't help me, but now it's completely helping me. It's exactly what I needed to know. Like that's how you build up that vast knowledge in your head, is by going down those dead ends and being frustrated.
Definitely, yeah. So yeah, that sums up all of our questions and all of our topics. So yeah, I think we can wrap up there. If you have any last minute questions, you can go ahead and put them in the chat, but within the next like 30 seconds or something. But I think we're gonna wrap up the show there. In terms of streaming, I think I'm gonna try to get back to streaming this Friday. I've said the last couple weeks that I haven't really been sure, trying to set my computer back up because I was doing some stuff with trying to fix my computer because I've been having some silly issues. I think I've fixed a lot of them. So I think I'm going to try to stream this Friday, going back to like the Android stuff. So that'll be at probably 8 p.m. Eastern. We'll let you guys know on Twitter and on our Discord, which you can also join.
Yeah, for reference, that was the debugger, kernel mode debugger that you were working on, or is that something else you're planning to stream? Or you haven't decided?
Yeah, the kernel mode debugger, I think. I might do something else, but I think it'll be the kernel mode debugger. So yeah, that'll be on Friday. So yeah, we're gonna try to get back into doing those streams as well. But yeah, if you don't tune in, then we will be back again next Monday at the same time, 3 p.m. Eastern. And yeah, so next week we will see you guys again.